Okay, so open to page 357. Okay. We are doing lesson 27.1, what is a function? Our learning targets, so our goals for today, are to be able to define relation and function and evaluate function. Our suggested learning strategies is to make a graphic organizer, visualization, discussion groups, create a representation, and take really good notes. So you can read this paragraph on your own, or you can listen to me read it. It's up to you. Mathematicians study relationships in the world around us in order to learn how things work. For example, the relationship between gasoline, air, and fire is what makes a motorcycle move. Understanding the relationship between carbonation and motion allows us to know that opening a bottle of carbonated drink that has been shaken is probably not a good idea. So what that last sentence is basically saying is if you shake up a Coke and then open it up, it's going to spray over everybody. So they make it sound a little confusing because it's a carbonated drink instead of just soda or pop, but that is what they're trying to get at. Alright, number 1. In a relationship, one item depends on another. In the example below, a car taking us home depends on there being enough gas in the car to reach the destination. List other relationships that exist in the real world. Alright, so our desired result is a car taking you home depends on having enough gas in the car. Another thing that some people want is they want milk for their cereal. I know I always like milk in my cereal. But in order to have milk in my cereal, I need to go to the store and get it. It's not just going to magically appear in my house. Okay. Another one is if you want a sharp pencil, you're going to have to sharpen it, right? It's not just going to magically be sharp. You have to sharpen it. Come up with 2 on your own. Okay, moving on. So a relation is a set of one or more ordered pairs. Here is the big important sentence that helps us with our learning targets. Okay? For example, the pairing of having enough gas in the car with the car taking us home is a relation. This relation can be written like that. So the important thing that you need to pay attention to is we have these brackets right here, and then we have parentheses and a comma. So I'm going to practice with the one that I did for number 2. Number 2 I put, so here, these little brackets, that starts my set. Okay, my pair is milk and cereal. And go to the store. Okay. And then that is the end of my set. Usually in a set you have more than one thing in parentheses. It's just working like this because we didn't come up with anything else that was related to milk. Okay, so if I did the next one, I would put my bracket for a set. Then my ordered pair would be sharp pencil and using a sharpener. Okay, and I'm going to put my close parenthesis and my bracket. The most important thing here is that you always have this guy, okay? You always have to have that. That's what tells you it's a set. Okay? And then the ordered pair part is this parenthesis, comma, and other parenthesis. Okay? All together, the whole thing is called a relation. Because sharpening a pencil and a sharpener, they have a relationship. They're a cause and effect. Let's look at our math terms over here. A set is a collection of objects, like points, or a type of number, like the real numbers. The symbol, these guys, indicate a set. An ordered pair is 2 numbers written in a certain order. So here's the thing with this. These aren't actually numbers, right? So it's not really a true ordered pair. I think they're just having us do it so we can practice before we put our numbers in there, because sometimes when we put numbers in there, it's confusing. Okay, most often the term ordered pair will refer to the x and y coordinates of a point on the coordinate plane, which are always written parenthesis x comma y close parenthesis. So you're kind of used to that, maybe graphing 4 comma 6 or something like that. The term can also refer to any values paired together according to the specific order. All right, let's go ahead and turn the page. All right, here we go. We're actually working with some numbers. So it wants us to write a relation using the table or graph. Okay, so for this guy, my coordinate pairs are going to be 2, comma 4. I'm going to put a little comma in between because I'm listing. -3, comma -6. Then put another comma in between because I'm still listing. And 5, comma -1. So all I did was I put my x, and I put a comma, and I put my y, and I put parentheses around it. Okay? To make it a set, I have to put my squiggle. All right, there we go. This whole thing is called relation when you have ordered pairs and your squiggle to indicate that it's a set. It's a relation. Next, we're going to do this one. This point right here is -3. So there's our -3 and 6. Right here, we go over to 2, so it's 2, and we up to 4, so comma 4. If we write that as a set, we're going to put our squiggle, -3, comma 6, and then 2, comma 4. It's really good if you have these in order. So like my -3 is lower than my 2, so that comes first. And here's just kind of explaining what we just did. We looked at the input x and output values y. Okay. We created each ordered pair, did that by writing the input value and the corresponding output value. We used braces, so that's good. And then that's the same answer we came up with, so that's good. Did all those steps. All right, go ahead and try these A on your own. When you think you've got it, click back and check your answers. Okay, so I'm just going to go ahead and write these real quick so you can check yourself. If you have any questions, go ahead and raise your hand. Okay, so there's the first one. Second one's a little trickier because you actually have to write your points. And then, alright, we're just going to list them. I didn't write that one. Alright, there you go. Hopefully you got these answers. If you didn't, make sure you're asking questions. Okay, next part. So a function is a special kind of relation in which one input has only one output. One way to think of a function is as a machine. A machine has an input and an output, and a relationship exists between the input and output. The machine receives the input and transforms it into the output. For example, a toaster is a machine. When bread is the input, the machine toasts the bread, and the output is toast. So, right here, here's our example. You put bread in a toaster, so that's why it's input, because you're putting it in. And then out comes toast, so that's why it's output. I'm going to do another one. All right, I put, let's see, I'm going to put a cake, or cake batter, in an oven. That's going to give me a cake. I'll come up with one more. I put my hair in a flat iron, also known as just like a I can't think of the name of it right now. A straightener. Okay. And then out comes straight hair or smooth hair. Come up with 2 on your own. Okay. In mathematics, if x is the input and y is the output, the value of y depends on the value of x. So they're saying that if you put an x into a machine and a y comes out, this guy depends on what you put in. Because it's like up here. If you put cake batter in the oven, you're going to get a cake. But if you put cookie dough in the oven, you're going to get cookies. So it just kind of depends on what you're putting in. Okay, then we say the relationship between x and y is determined by the function or rule. The function changes or transforms x into y, so y is a function of x. That's just fancy words. Okay? Alright. A function represented by the equation, blah, 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 has inputs labeled x and output labeled y. The diagram below represents that function. Alright, so what we're saying is if we put x into our formula or our rule, we're going to get our y. Which kind of makes sense because it says equal y, so whatever we plug in here is going to equal y, right? Alright, let's try that out. So they say if x equals 5, find out what the output is. So there's our 5. We plug that in. We're going to have 5 plus 5 equals y. That's our x. And that's going to give us 10. So y equals 10. Let's try -3. So I put -3 in. If I put that in my machine, I'm going to get 5 plus -3, which is going to give me 2. Okay. Now I'm going to put in 0.03. We're trying to get a little tricky because they're putting decimals in there. Okay, 5 plus 0.03. So that one's a tricky. I'm going to go ahead and do it over here. So whenever you're adding decimals, you want to make sure that you line up your decimal points. Okay? That's going to give me 5.03. Okay, and this last one, I'm going to try to do it without even plugging in. I bet I can do that in my head. Ooh, that looks kind of freaky. Got a little freaky there for a second. Oh no. Technical difficulty. Stand by. Alright, there we go. Next, we're going to plug in -1/2. So 5 plus -1/2 is the same as just doing 5 minus 1/2. Okay, and that's going to give me 4 1/2. Okay, so my y value is 4 1/2. It says, reason abstractly. For this particular function, is it possible to have the same y value when using 2 different x values? Alright, so the answer is no, because every time we go up by 5. It doesn't matter what your x value is every time you add 5 to it. So if I plug in 1, I'll have 6. If I plug in 2, I'll have 7. There's no way I can have the exact same number. Alright, next. Complete the function table using the given input x values and determine the corresponding output values based on the given function. So that's a lot of fancy words that's saying that we're going to do the exact same thing we just did. The only difference is this time you get to pick your input values. Well, since usually we plug in these numbers to graph a line, I'm going to pick -1, 0, 1, and 2. First of all, they're easy numbers to plug in. Second of all, they'll give me a good graph if I actually graph my points. Okay, if I plug in -1 into my equation, I'll have y equals 2 times -1 minus 1. 2 times -1 is -2, and -2 minus 1 is -3. So that gives me y equals -3. I'm going to write -3 right there. Now I'm going to plug in my 0. 2 times 0 minus 1. 2 times 0 is 0. 0 minus 1 is -1. So that's where I get my -1. Now I'm going to plug in my 1. I equals 2 times 1 minus 1. 2 times 1 is 2 minus 1. And then 2 minus 1 is 1. So that gives me my last point. All right. Next one. Now I'm going to plug in 2. Y equals 2 times 2 minus 1. 2 times 2 is 4. And 4 minus 1 is 3. There we go. So it's important to notice here that we didn't have any repeats. These are all different numbers. That's one of the important things about a function. You can't have any repeating output values. All right, go ahead and try number 6. Here is my example. So I'm going to pick a y, then I'm going to pick any number to put in front of my x. I'll do 3. And then I'll add 1. I'm going to do the same input values. Okay. 3 times negative 1 is negative 3, plus 1 is negative 2. 0 times 3 is 0, plus 1 is 1. 1 times 3 is 3, plus 1 is 4. And 2 times 3 is 6, plus 1 is 7. That's the example of my function. Yours is probably going to look different than mine. Actually, it's definitely going to look different than mine. All right, write the x values from the function that you created in item 6 as ordered pairs. So what we're going to do is we're going to put our parenthesis, the first value, so x, and then our y. Then we're going to do 0, 1. Then 1, 4, then 2, 7. So all you're taking is your input, parenthesis, comma, parenthesis. All right, next one. We are good to go. That's over.